Alright, I'm going to go through this really quickly. This is video 8D. If you haven't seen 8C, you definitely should, okay? I'm going to go fast because it's late on a Saturday night. The custodians just told me that they got to lock up in about 12 minutes, so we're getting the fast version of this one. This is like section 8.6. Remember what we have. We can use a catapult to launch Fluffy upward off a cliff, and then she's going to land safely in the water. Trust me, everything's going to be fine. Fluffy's used to this. She has a life preserver. Anyway, so the function for the height of Fluffy after t seconds is the linear term is she's going up at 64 feet per second. The constant term is how high the cliff is that she's being launched from. The quadratic term is the force of gravity pulling her back to Earth. So here's what we have. If you want to grab your workbook for section 8.6, we're going to quickly go through a problem. If you see this as your function for height after t seconds, 192, height of the cliff, upward velocity, and the force of gravity. So it says, there's your function. That's like part A of number 1. Find the time at which the object hits the ground. If you set this height equal to 0 and solve, then you're going to know when it's going to hit the ground down here at 0. Velocity. What's the velocity? Well, we know the velocity is the first derivative. I'm sorry, never mind. I just got that wrong. V of t would be the upward velocity of the object. So that's going to be 64t. So that's the upward initial velocity that we're launching it with. Part D, the time at which the object has a maximum height. If we use calculus, we can take the first derivative of this and set it equal to 0, and that will be the time at which we will find the maximum height. So first derivative equal to 0, we'll do it that way. The maximum height, once we have that time that we got from what we set the first derivative equal to 0, remember to put that value for time back into the original function. That will give you the height at that particular moment of time. So we're finding the ordered pair associated with the critical value, where t is the time and h is the height. Then we get to part F, the velocity of the object at impact. Well, when it's at impact, we want the velocity of that. So we would like to know what that is. We can set the first derivative. We can use the first derivative, and at that time we put that time into the first derivative, which tells us how the height is changing. The first derivative is the rate of change in height. That will give us the velocity at impact. So find the time from this, set this equal to 0 to find the time when Fluffy hits the water, and then put that time into the first derivative, because the first derivative will give you the rate of change in height, which is the velocity at that moment of time. So that's how you will do part F. Then when you do part G for these problems in section 8.6, what's the speed of the object when t equals 5? Remember, speed, we don't care about whether we're going upward or downward. We're actually going to be coming downward at that point. But so all we need to do is put 5 into, now wait, so we want the speed. The speed is the absolute value of the velocity. So find the velocity at 5 seconds. It's going to be a negative velocity, but they're asking for speed, so you just take the absolute value of it. So the speed would be the absolute value of what you get when you plug 5 seconds, 5 in for t, into the first derivative, which gives us the velocity. Then h, what's the time when the object is speeding up? Well, it's speeding up if the acceleration is up, and so we're going to be speeding up when we get past this point right here. We're actually slowing down until we get here. It's after the max that both the velocity will be negative and the acceleration is negative, so we're speeding up whenever acceleration and velocity have the same sign. This is not cubic, so we never had a situation where we were, the velocity was increasing while the acceleration was increasing, so there's no speeding up in the positive direction. There was only speeding up in the negative direction. Look at that 8C video if you need to. And finally, part I, the last part, the total distance traveled by the object. all you need to do is figure out what was the max height, and we can take the height at the max, and then and subtract from that the 192, and then so that was let me just say here the difference in the height here, whoop, from the max minus the 192 that we started with, and then whatever the max is, that was the height that Fluffy's going to fall all the way down to the surface of the water. So just add that max height as well, and that will give you the total distance traveled upward and downward. So I hope that helps for section 8.6, and I gotta get out of here.